we're given this function and we're asked to evaluate two different limits for it or show that they do not exist. So the simplest way to start is just with the plug and chug. We plug in for the first one, x equals 0, y equals -1, and we'll see what we get. So plugging in x equals 0 into our numerator gives us 0 squared, -0 squared, which is simply 0. And then for the denominator, again, we have x equals 0, so that's 0 plus 8 times, now y is -1. So -1 minus 1 is -2. Quantity squared is 4. So 8 times 4 is 32. So we wind up with 32 as our denominator, which, well, this one simply evaluates to 0. So yes, this one, the limit does exist and it evaluates simply to 0. Now I think you and I both know that both of the answers are not going to be this easy. So looking at the second one now, we have x again is equal to 0. So our numerator is 0. Our denominator now, we have y. Again, this is 0. Y is now 1. So that gives us 1 minus 1 is 0. 0 squared times 8. That gives us the denominator of 0. Now, as tempting as it would be just to say, oh, we're done, it evaluates to 0, that's not the correct answer because we have an undefined denominator being 0. So that is, the solution isn't 0. It's not, the limit isn't existing there. Normally what we would do would be with a single variable, we would have done L'Hopital's rule. However, that's for one variable equations. When we have two variables, this way we have to do the two-path test since we have two variables. So the first thing we need to look for is an equation that's going to converge at 0, 1, giving us a slope with x in relation to y. So our line equation is going to be y equals mx plus, well, this one is pretty straightforward. We have a one-to-one relationship, and y is simply, in this case, x plus 1. So that's our equation that then we'll redefine what the limit that we're taking by saying this is now the limit of the same equation, but replacing now -x squared over, we still have our 3x squared plus, now we replace, we have y minus 1. Well, that simply replaces out. Y minus 1 is equal to mx. And that quantity is squared. We're not ready to plug in, and this is going to be evaluated as x approaches 0. So we can't just plug it in yet because still we're going to have 0 over 0, but what we do see is that we can factor out from the top and bottom x squared. So now we'll redefine this as the limit as x approaches 0. Now we have, as our numerator, factoring out x squared, we have -1 over, factoring out the x squared, is 3 plus, okay, now factoring that out, we have, oops, I forgot the 8 here, because originally we were at 8 plus 8. Sorry about that. So now it's 8 times the x squared factors out. It's 8m squared. So looking at this for the two-line test, we have to evaluate what the results would be coming in with different line angles. For example, let's say if m is equal to 1 as compared to m equal to 2. Well, obviously we see if we change the value of m down here, it's going to change the value of the entire limit. on this. So basically we're concluding here that it's not going to converge to a single point. A different path on this is going to result in a different answer for the limit. So in conclusion, we're basically saying that the limit does not exist. In evaluating then this problem, we're looking to check for continuity. And so we could see here at this point, 0, -1, it does have continuity, and it is at 0. However, here we see that at the point, we're looking at the point 0, 1, the function is not continuous.